Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 25, three-dimensional geometry. Last class, vectors gave us direction and two kinds of multiplication. Today, we point them into space and build the geometry of three dimensions. A line needs just a point and a direction. A plane, a point and a normal. From those two ideas flow every angle and every distance. Even the tiny gap between two lines that neither meet nor run parallel. Direction cosines, the line, the plane, and the shortest distance between skew lines. One idea at a time. Here is what you will master today. First, direction cosines and direction ratios. Second, the equation of a line in space. Third, the equation of a plane. Fourth, the angles between lines and planes. And fifth, distances and the shortest distance between skew lines, one idea at a time. 4 ideas. Run this whole chapter. Look at them together first. Direction cosines. The cosines of the angles a line makes with the three axes and cosine squared alpha plus cosine squared beta plus cosine squared gamma equals 1. Direction ratios. Any three numbers proportional to the direction cosines. Lines and planes. A line needs a point and a direction. A plane needs a point and a normal. Mass aligned, vectors do the heavy lifting. A point plus a direction defines everything in space. Now look at the picture, a line in space and its direction cosines. Direction cosines, L, A, M, and N, are the cosines of the angles alpha, beta, and gamma that the line makes with the x, y, and z axes. The identity, L squared plus m squared equals 1, that is cosine squared alpha plus cosine squared beta plus cosine squared gamma equals 1. Direction ratios A, B, and C are any numbers proportional to L, M, and N. Recover them. To get the direction cosines back, divide the direction ratios by the square root of their sum of squares. Now the line itself, in two forms. Vector form, r equals a plus lambda b, start at the point A and move along the direction B. Not Cartesian form, x minus x1 over A equals y minus y over B equals z minus c1 over C. The symmetric equation through 2 points. The direction ratios are simply the differences of the coordinates of the 2 points. The angle. Between two lines, the cosine of the angle comes from the dot product of their direction vectors. Now the plane. Normal form. A plane is fixed by a point on it and a normal vector n that is perpendicular to it. Cartesian form. A x plus by plus cz plus d equals 0, where a, b, and c are the direction ratios of the normal. 3 points, or equally from a point and two directions lying in the plane. Two planes. The angle between two planes is the angle between their normals. Line and plane. The angle between a line and a plane uses the sine, not the cosine, of the angles the line makes with the normal. Now look at the picture. The distance from a point to a plane. The distance. Drop a perpendicular from the point to the plane. Its length is the distance. The formula. It is the modulus of ax1 plus by1 plus cz1 plus t divided by the square root of a squared plus b squared plus c squared. The normal. The perpendicular runs along the plane's normal vector n on the plane. The distance is 0 exactly when the point lies on the plane. Now the most beautiful distance of all. Between skew lines. Skew lines. Two lines that neither meet nor are parallel. They lie in different planes. The shortest distance. It is the length of the common perpendicular to both lines. The formula. The scalar triple product of the connecting vector and the two direction vectors divided by the magnitude of their cross product. Coplanar. If the two lines are coplanar, the shortest distance is 0. The scalar triple product vanishes. Point to line, and the perpendicular distance from a point to a line is found with the cross product. Now the formulas that earn marks. Direction cosines. L squared plus M squared plus N squared equals 1. Point to plane. The modulus of Ix1 plus By1 plus Cs1 plus D over the square root of A squared plus B squared plus C squared. Two planes. The cosine of the angle between them is the cosine of the angle between their normals. Now match each object to its description. L squared plus M squared plus N squared equals 1 goes to the direction cosines. R equals A plus lambda B goes to a line in space. X plus Bi plus Cz plus D equals 0 goes to a plane. And the common perpendicular goes to the shortest distance between skew lines. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The sum of the squares of the direction cosines is 1. Correct. Statement 2. The angle between two planes is the angle between the lines. Wrong. It is the angle between their normals. Statement 3. Skew lines are neither parallel nor intersecting. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the plane angle claim in statement 2. Now the two mistakes that quietly cost marks. The truth, the direction cosines satisfy L squared plus M squared plus N squared equals 1. The trap, confusing direction cosines with direction ratios. The ratios are only proportional, not the cosines themselves. The second truth, the angle between two planes is the angle between their normals. The second trap, using the cosine for a line and a plane. That angle uses the sine of the angle the line makes with the normal. Now, test yourself. Answer in your head before the reveal. That is how JEE speed is built. Here we go. Question 1. The sum of the squares of the direction cosines. 1. Question 2. The vector equation of a line. R equals A plus lambda B. Question 3. The Cartesian equation of a plane. Ix plus Bi plus Cz plus D equals 0. Question 4. The distance from a point to a plane. The modulus of x1 plus by 1 plus cz1 plus d over the root of a squared plus b squared plus c squared. And question 5. The shortest distance between skew lines uses the common perpendicular. Let us gather it all in one breath. Direction cosines L squared plus M squared plus N squared equals 1, and direction ratios are proportional to them. The line or equals a plus lambda b or the symmetric Cartesian form. The plane A x plus bi plus cz plus d equals 0 with normal A, B, C. Angles between lines by the dot product, between planes by their normals. Distances point to plane by the formula, and skew lines by the common perpendicular. Next class, probability, conditional probability, Bayes theorem, and the binomial. All of three-dimensional geometry rests on two humble ideas. A line is a point plus a direction, and a plane is a point plus a normal. From them, every angle is a dot product between normals or directions, and every distance is a projection along a normal. Even the shortest gap between two skew lines is just the common perpendicular. Read off a scalar triple product. Master the direction cosines and these two objects, and the whole chapter is bookkeeping. Next class, the mathematics of chance, probability. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack JEE. I will see you in the next class.